Hello students, this is my second lecture on friction topic. In the first lecture, we had covered 13 problems on block friction. Majority of the problems were of the blocks without dimensions. So FBD of the block was example of concurrent force system. So we had applied two equilibrium conditions. In this lecture, we'll take few problems of block friction where dimensions are given. So if the dimensions are given, FBD of the block will become example of general force system. That means three equilibrium conditions will be applicable. Now, today we start first with the concept of tipping. What is tipping? To understand the concept of tipping, we'll consider example of cupboard. You all have seen the cupboard. You want to push the cupboard. You'll apply the force P. Look into the diagram. There is a cupboard which is resting on the horizontal plane. The plane, there is a friction between the cupboard and the plane. Force P is being applied on the cupboard to push the cupboard towards right. Initially, what you see that initially when you apply the force P at lower height, then the cupboard will start sliding. Cupboard will start sliding. Now keep the value of force P constant. Slowly increase the height h at which the force P is applied. You will see that initially at lower height, the cupboard will continue to slide, will move as a sliding motion. But a stage will come where when the cupboard, instead of sliding, it starts tipping. Tipping means what? Turning, overturning. All right. These are some of the words which are used for tipping. All right. So it will tip about the other corner. The force P is being applied from left to right. All right. It will tip or turn or rotate about opposite corner. At the instant of tipping, the height h at which the force P is applied will be maximum. And also the normal reaction and friction force will act at point B, because entire width of the cupboard will be lifted off. So it loses contact with the plane except corner B. So corner B is in contact with the plane. So normal reaction and friction force will act at point B. Again, we need to understand that tipping is possible only when dimensions of the body are given. If the dimensions of the body are not given, it is example of concurrent force system. And in that case, only sliding can happen. See, tipping can happen only when dimensions of the body are given, and tipping will take place about the opposite corner. We'll understand it in the subsequent solved problems about tipping. All right. In the previous lecture of friction, I had covered 13 problems. 13 more problems will be covered in this lecture. 4 problems I'll cover on block friction. 5 problems I'll cover on wedge friction, and then 4 problems will be covered on the last part, that is ladder friction. Read question number 40. For the block shown in the figure, find the minimum value of P, which will just disturb the equilibrium of the system. Now you can see that. Look at the diagram given. You are given with a block which has dimensions. Force P is being applied at the fixed height. Force P is applied at the fixed height. All right. So as the dimensions of the block are given, force P is applied at fixed height. You do not know whether it is on the verge of sliding or it is on the verge of tipping. So we will consider two impending motions in this case. The first case, I'll consider impending motion of this block with sliding. Now just observe that. What difference will come when I'm considering the impending motion of this block with sliding? So P will be acting at C as it is, be it vertically down at the CG body. Normal reaction and friction force will be distributed over the entire surface. All right, impending motion will be to the right, friction will be acting to the left. We write sigma Fy is equal to 0, N1 is 60 Newton, sigma Fx is equal to 0, I write P is equal to 0.5 F. That gets you the value of P as 30 Newton. That means if the force P is applied at point C as shown, value of P required to start the motion of this block with sliding is 30 Newton. All right. Now we'll see that what is the value if we consider the motion, impending motion of the block with tipping. what difference comes, what changes will be there. Now I'm considering impending. I'm assuming that the force P applied on the block at C is of that magnitude, so that it just starts tipping over. So impending motion of the block with tipping, P will remain same as it is. Weight will act at the CG. Dimensions will be required for tipping, and you should understand that force P will cause the block to tip about point P. So entire surface of the block will be lifted off except point B. Only point B will be in contact with the plane. So normal reaction and friction force will act at point B. So normal reaction vertically upward, and as impending motion or tipping is towards right, friction is to the left. Students, here tipping means what? If you want to consider tipping, tipping means turning. Turning means what? Rotation. All right, that means movement equilibrium condition is must to be applied. We should apply the movement equilibrium first, when, or necessarily it is to be applied when tipping is to be considered. So I start with movement equilibrium condition about B. Sigma MB is equal to 0. It is example of general force system. If I take movement about B, N1 and 0.5 N1 will go off. P into 10 is clockwise, 60 into 4.5 is anti-clockwise. So you get 27. Now you saw that impending motion of the block uh, with sliding happens at P is equal to 30 Newton. Impending motion of the block with tipping happens at 27 Newton. He is asking minimum value P required that will just disturb the equilibrium. So the motion will impend at 27 Newton only. So we will say that minimum value P required to disturb the equilibrium is 27, smaller of the two values. And equilibrium will be disturbed in the form of tipping, as it is understood with the value of P is 27 Newton, which is smaller or lesser than value of P 30 Newton with slide. Okay. We move to the next sum. Another sum of tipping only. I read this sum. If 1500 Newton cupboard is to be shifted to the right by horizontal force P as shown, find the force P required to just cause the motion and maximum height up to which it can be applied. Now you can see that this is the cupboard has been given with the dimension. Its weight is given 1500, which will act at the CG of it. Force P is being applied at height h. He is asking you to find the maximum height h. He is asking you to find maximum height h at which the force P should be applied just to cause the motion. All right, P required to just cause the motion. So here max height h will be maximum when this cupboard is on the verge of tipping. So we'll consider FBD of the cupboard at the instant of just tipping. Tipping will take place about this corner as P is applied at height h so as to cause the tipping. So tipping will happen about this corner. So normal reaction and friction force will act at point A. Force P is applied at height h. Weight 1500 vertically down. Width of the cupboard is 0.8, so 0.4, 0.4. All right. And normal reaction will be obviously upward and friction will be to the left, as impending motion will be towards right. Now here we write sigma Fy is equal to 0. N1 upward is equal to 1500. Sigma, right? After that, we take sigma Fx is equal to 0. P is equal to 0.25 N1. N1 is known to you, get P as 370. Then we take movement about A. When you take movement about A, sigma Ma is equal to 0. N1 and 0.5 N1 will go off. P into H is clockwise about A. When you take movement, N1 and 0.25 N1 will go off. P into H is clockwise. 1500 into 0.4 is anti-clockwise. Substitute the value of P 375. You'll get the value of H as 1.6. So maximum height which can be applied to cause the motion here is 1.6 meter. Okay. Now we take next sum. Here we have a circular body. Here we have the circular body with dimensions. So obviously free body diagram will be example of general force system. Obviously free body diagram will be example of general force system. I read the sum. A thin hoop of radius 1 meter and weight 500 Newton rests on the rough inclined plane. What minimum coefficient of friction is needed for this configuration? What is the tension in the wire which is parallel to the implement? Students, hoop means like a ring. All right. We draw FBD. You can see that this he says that this tension in the wire is parallel to the plane. So we draw free body diagram of the hoop. When we draw free body diagram of the hoop, weight will act vertically down. We have shown. All right. Normal reaction will be acting upward. Impending motion is down the plane. Friction will act up the plane. So normal reaction N1, mu N1. As the hoop is resting in inclined plane, will resolve all forces along the plane and normal to the plane. So here I'll have to resolve weight. See, plane is making 30 degree with horizontal. Normal reaction will make 30 degree with vertical. So this is 500 cos 30 and this is 500 sin 30. We can start with sigma Fy is equal to 0, N1 up is equal to down, that is 500 cos 30. Then we can write sigma Fx is equal to 0, T plus mu N1 is equal to 500 sin 30. Upward force is equal to downwards forces. All right. Then we take moment about A. About this point about the right take moment. Which forces will go off if I'm taking moment about A? You can see that N1 will go off, 500 cos 30 will go off, mu N1 will go off. So you will take moment of 500 sin 30. 500 sin 30 into 1, that is radius clockwise. All right. What is going to be anti-clockwise? It's going to be T into 2. T into 2 is anti-clockwise. 500 sin 30 into 1 is clockwise. So you get the value of T as 125 meter. Substitute the value of T in equation number 1. Substitute the value of T in equation number 1. Substitute the value of N1 in equation number 1. You get the value of mu as 0.289. And that's what is, he has tension the wire, all right, and he has coefficient of friction. So both the unknowns have been added. Let's move to the next sum. Now, this problem involves more geometry, so need to be a little careful in understanding the solution of this sum. A hemispherical body of uniform density rests on the horizontal surface and is subjected to a force P at the rim as shown. If P is increased slowly and always kept normal to the rim surface, so force P applied is always normal or perpendicular to the rim surface. Determine the coefficient of static friction. If the angle of tilt theta is 40 degree, at which slipping occurs, also determine the resultant reaction at A and force P. Take R, that is radius is equal to 1 meter, and weight of the solid hemisphere is 500 Newton, and CG of the solid hemisphere is at a distance of 3r by 8 meter from base. Well, students will draw free body. This is the hemispherical body has been shown to you here. You can see that it's of radius r, which is 1 meter. All right, angle of tilt is 40 degree, force P is applied, normal to the diagram has been drawn to the bigger scale so that every force applied and resolved parts are very clear. Now you can see that this is the rim, which is 40 degree. Rim is making 40 degree. All forces, reactions, lines normal to rim will make 40 degree vertical. You can see that force P is normal to the plane, so it will make 40 degree with vertical. So P cos 40 and P sin 40, we have resolved the parts. Its weight will be acting at CG of this solid hemisphere. It is at distance what? 3r by 8. R is 1 meter. So you get OG distance is 3r by 8. Over here, it is mentioned. All right. Now, when it is on the verge of sliding to the right, friction force will act to the left, mu N1. Normal reaction will be acting at A. All right. Here, in this right angle triangle, we have completed a right angle triangle with OG as hypotenuse, which is making 40 degree with the vertical. So in triangle OBG, OG is 3r by 8 or 3 by 8 meter as radius is 1. OB is 3 by 8 cos 40. BG is 3 by 8 sin 40. Similarly, in this right angle triangle OCE, this is OC is radius 1 meter. So CE will be what? 1 cos 40 and OEs will be 1 sin 40. All right. Then we start with moment equilibrium condition about A. Why we decided to apply moment equilibrium condition about A? Because two unknowns will go off. What are the two unknowns will go off? Mu and N. So we take it 500 into BG. BG is what? 3 by 8 sin 40. That is clockwise. Then P sin 40 is like this. P sin 40. So this distance is going to be perpendicular distance. OA is radius R. OE we have got it 1 sin 40. So distance A is going to be 1 minus 1 sin 40. And so P sin 40 into AE distance. A is 1 minus 1 sin 40. That is perpendicular distance. So again, P sine 40 about A gives clockwise. P cos 40 into CE distance, that is 1 cos 40, that gives you anti-clockwise movement. So anti-clockwise movement has been taken on the right side. Clockwise movements have been taken on the left hand side. So that gets you the value of P. Then we write sigma Fy is equal to 0. Upward force is equal to downward. N1 up is equal to P cos 40 plus 500. You substitute the value of P into it, you get the value of N. Then you take sigma Fx equal to 0. P sine 40 is equal to mu N1. Right? You substitute the value of P, you substitute the value N1, you get the value of mu. But he is not only asking the value of mu, he is also asking resultant reaction at A. Resultant reaction at A will be resultant of normal reaction and friction force mu N1. So we draw a separate diagram and with the heading resultant reaction at A. N1 is vertically up 758.46 meter. All right. And friction is to the left, mu N1, 216.87. We substitute the value of mu and N. Resultant reaction RA will be N1 square plus mu N1 square. That's what we have found it out. It comes 788.86. Then resultant reaction will make some angle with normal reaction. That is called as angle of friction. We learned that angle of friction is the angle which the resultant of normal reaction and friction force makes with the direction of normal reaction. So tan phi is equal to what? Mu N1 upon N1. Or directly we understand phi is equal to tan inverse of mu. Tan inverse of mu. Substitute the value of mu, you get the value of phi. And phi is the angle what the resultant reaction is making with the vertical. Although if you take it the angle like in any other problem, we take it alpha angle what resultant makes with the horizontal. So then also you can find it in normal manner. But there is no need as mu was already us. Mu is already with us. So phi can be determined as tan inverse of. So these were all about the problems about the block friction, where you have seen in all the last 4 columns, dimensions of the body had come into consideration. And so FBD of the bodies were example of general force system. Now we are ready to move to the type 2 problems, that is on wedge friction. So we will first understand what is wedge and what are the advantages of using the wedge into the system. Wedges are tapering wooden or metal pieces of negligible small weight. They are used to raise heavy blocks, heavy machines, beams, columns, etc. during their erection or when they are being fixed into the position. See, one of the use of lifting or raising or pushing the heavy machines, heavy parts, heavy beams, columns is that using a crane. But crane is something what cannot be called every time. So what is done using the wedge, which is a lightweight tapered or piece, right, of negligible small weight. Using this wedge, the heavy weights, blocks, machines are raised, pushed, all right, or to move by small distances. So this is the advantage of wedge friction. So wedges are used to reduce the effort of for raising or shifting or moving the heavy machines or parts. That is one. Also, using the wedge, direction in which the effort is applied is conveniently applied. So that means the here example it becomes using wedges, efforts can be applied in the convenient direction. As per your syllabus, when you are solving any problem of wedge friction, you will have to draw free body diagram of one wedge and one block. All right. Wedge is something on which the effort is applied. Block is something what is to be raised, to be lifted, to be pushed, or to be raised. As per your syllabus, even if 2 wedges are given, you will be required to draw FBD of 1 wedge. Even if the 2 blocks are there, you will be required to draw FBD of 1 block only. So in short, you will be drawing FBD of 1 wedge and 1 block. Wedge and block both will be given to you without dimensions. Wedge and block both will be given to you without dimensions. So both will be example of concurrent force system. So in short, when you draw the free body diagrams in any wedge problem, you will be drawing FBD of 1 wedge and 1 block. First, we'll apply the equilibrium conditions on the block, and then we apply the equilibrium conditions on the wedge. Now we move to the problems with basic understanding. All right. This is our first problem on wedge friction. Determine the force P required to move the block A of weight 5000 Newton up the inclined plane. Coefficient of friction between all contact surfaces is 0.25. Neglect the weight of the wedge and the wedge angle is 15 degrees. See, coefficient of friction for all surface given 0.25 and wedge angle is 15 degrees. Wedge angle means the inclination of the wedge with the horizontal is 15 degrees. Now, looking at the diagram, we understand that the force P is being applied on wedge B and block A is to be raised. So, direction of impending motion of the block A will be up the plane. Impending motion of the block A will be up the plane, and impending motion of the wedge B will be towards left. Impending motion of the wedge B will be towards left. All right. Now we draw free body diagram of the wedge and block simultaneously. Why simultaneously? Because certain forces are interconnected. We'll understand. So draw the wedge in the same shape as it is over here. We have drawn it. First show only weight. Weight of it is 5000 Newton. We have shown it. Then we draw wedge on the other side. Right? We show force P on it. Its weight is negligible, so not to be shown. Then we show normal reactions first. We understand. Be careful. First we show normal reactions. So first I have shown there will be normal reaction from this plane on the block A, N1. All right. Then we show normal reaction on this surface of the block N2. This will be towards the body equal and opposite. This is N2 towards the block. This is N2 towards the wedge. This is N3. Clear? Now this wedge for the given condition tends to move to the left. Friction will be towards right. So this is N3 is normal reaction. Friction will be 0.25. Here this normal reaction is N2. Friction will be 0.25 N2. Is that understood to everybody? Now this surface is making 15 degrees horizontal. Friction is tangential or parallel to it, where 15 degrees with horizontal. All right. This surface is making 15 degrees horizontal. Normal reaction make 15 degrees with vertical. So we don't write the resolved parts, but we show the resolved parts and show the angle. So again, I repeat that here this surface is making 15 degrees horizontal. Friction being parallel to that will make 15 degrees horizontal, and its two components will be like this. Right? Normal reaction will make 15 degrees vertical, so it will be like this. Is that all understood, this everybody? Then we come to this wedge. On this wedge tends to go up, so friction here will be down, 0.25. Now this surface is 60 degrees with the horizontal, so friction parallel to it will make 60 degrees horizontal. Normal reaction will make 60 degrees with vertical. All right. Resolved parts have been shown. Now we come to this friction. Yes, this friction is important to understand because we understand impending motion of block is upward, so friction will be in opposite direction. But how to mark friction on this surface? See, this block and wedge are in contact. This block and this wedge are in contact. So friction between the two parts in contact will be equal and opposite. Based on this impending motion, we understood the direction of this friction force, 0.25 and 2 is up. So here it will be down. So exactly opposite we will be showing it, because in any case when the wedge and block are in contact, so normal reaction and friction force between them will be equal and opposite. This was well understood, 0.25 and 2 towards right, so it will be towards left. Now this surface is 15 degrees with horizontal, so friction will be 15 degrees horizontal as marked, and normal reaction will be 15 degrees with vertical. Resolved components are shown on the tail side. All right, as wedge and block both are given without dimensions, both will be example of concurrent force system. Total number of unknowns will be 4, right, as 2 equilibrium conditions will be on each free body diagram, right? So we start solving it from this free body diagram, right? Since there are always, we start solving it first from the free body diagram of block, then we go to the wedge, because our final unknown will be on the wedge. All right, and initially block will be workable with 2 unknowns, and initially if you start with wedge there will be 3 unknowns. You can see that N2, N3, and P. But if I solve first block, then N1 and N2 will be known to us. Once N1 and N2 are known to us, then N3 and P can be arrived at from the wedge. Now let's write sigma fx is equal to 0. Sigma fx is equal to 0. You can see that N1 sin 60 to the right, 0.25 N1 cos 60 is to the right, equal to N2 sin 15 to the left, and 0.25 and 2 cos 15 is to the left. This is sigma fx equal to 0. Towards right is equal to towards left. Now we write sigma fy is equal to 0. When I write sigma fy, this can be further simplified. We have written it, n1 coefficient has been written, then n2 coefficient, and right side is 0. Then sigma fy is equal to 0. n1 cos 60 up, n1 cos 60 is up, n2 cos 15 is up, down 5000 plus 0.25 n2 sin 15 and 0.25 n1 sin 60. Then again here coefficients of n1 and n2 are arranged, and the equation is written in simplified version. Solve equation number 1 and 2, you will get the value of n1 and n2. You can use the calculators for solving the simultaneous equations, and n1 and n2 will be arrived. Now we come to the free body diagram of this wedge. When we are applying the equilibrium conditions on the wedge, my final unknown is P. My final unknown is P. So which will be reflecting on sigma fx equal to 0, which will be reflecting on sigma fx equal to 0. So you should start with first sigma fy, because that P will be our last node. Sigma fy, n3 is up, 0.25 n2 sin 15 is up, is equal to n2 cos 15. This is what is that gets to the value of n3, because n2 is already known here. Sigma fx is equal to 0, P is equal to 0.25 n3 plus 0.25 n2 cos 15 plus n2 sin 15. Substitute the value of n2 and n3, value of P is arrived. So this is a typical problem of the wedge friction, where FBD of block and FBD of wedge are drawn. We start drawing free body diagram of both the blocks simultaneously. Also, we need to start solving writing equilibrium conditions from the block first, so that both the unknowns will be arrived. Then we go to the wedge, and then equilibrium conditions are arrived to find the final unknown. All right, we are ready to move to the second problem. I'm reading the sum. Find the force F to have the motion of block A impending up the plane. Take coefficient friction for all surfaces in contact as 0.2. Consider the wedge B as weightless. So students, here you have been given a block of weight 200 Newton. Mu for all rubbing surface is given to as 0.2. This block is in contact with the plane, which is 75 degree with horizontal. This wedge is having this slant surface 15 degree. For impending motion of block A upward, wedge on which force F is applied will have the impending motion towards left. So based on the wordings of the sum, we understand that block A will have the impending motion up the plane, and wedge will have the impending motion towards left. So now we are ready to draw free body diagram of the wedge and the block. So first we draw the block and then wedge as the boxes. Then weight of the block is 200 Newton. This side we will be taking as the two surfaces, as this surface is making 15 degree horizontal and this surface is making 75 degree horizontal. That means the two surfaces of the block A are mutually perpendicular. Two surfaces of the block are mutually perpendicular. So this normal reaction is N1, this normal reaction is N2, this normal reaction is N2, this normal reaction is N2. All right. As this wedge tends to move to the left, friction will be towards right. So this is 0.2 and 3, this is 0.2 and 2. This surface is making 15 degree horizontal, so friction will make 15 degree with horizontal. Normal reaction will make 15 degree with vertical. Then we come to this side. This block has a tendency to go up, so friction will be in opposite direction, 0.2 and 2. This friction 0.2 and 2 has been taken from here, equal and opposite. On this wedge, we understood that friction is towards right, 0.2 and 2. So here it is 0.2 and 2 down or to the left. All right. As we take X and Y are the two surfaces of this block which are mutually perpendicular. So we don't need to resolve the normal reaction and friction force on this block. We need to resolve only this weight. How will you resolve weight? This surface is making 15 degree with horizontal. Any force or reaction normal to the plane will make 15 degree vertical. So this is 15 degree, 200 cos 15 and 200 sin 15. I have not written the resolved part. we can directly take into consideration. So it is easy to work upon. Sigma fx is equal to 0. N1 is equal to 0.2 N2 plus 200 sine 50. Sigma fy is equal to 0. N2 is equal to 0.2 N1 plus 200 cos 50. Solving the two equations, you get N2 and N1 will be arrived. Now we come to FBD of wedge. In FBD of wedge, my final unknown is F. My final unknown is F. So that will be reflecting on sigma fx equal to 0. So first we apply sigma fy is equal to 0. Sigma fy is equal to 0 when we apply, N3 is up, 0.2 N2 sine 15 is up, is equal to N2 cos 15. So that gets you the value of N3. Then we apply sigma fx equal to 0. Sigma fx equal to 0 is F is equal to 0.2 N3 plus 0.2 N2 cos 15 plus N2 sine 15. That gets you the value of F. That gets you the value of F. So in this problem, we took distinct advantage of taking the reference axis along the two edges of the block. Reason for that was two edges of the block were mutually perpendicular. That's why this advantage could be taken. Let's move to the next sum on wedge friction. Problem number 3. Two 6-degree wedges are used to push a block horizontally as shown in the figure. Calculate the minimum force P required to push the block of weight of 10 kilotons. Take mu for all surface as 0.25. Now students, if you look into the given diagram, there are two wedges. This is one, this is another. This is block of 10 kilotons. This wedge, this one, it is fixed in position. I mean, this is going to remain stationary throughout, right? Why? Because this wedge is in contact with horizontal plane as well as vertical. All right. This wedge on which force P is applied will tend to go down. This wedge on which force P is applied will tend to go down. The block of 10 kilonewton will tend to move towards right. So we understand the direction of impending motion for the wedge and block. The wedge on which force is applied tends to go down. The block will tend to move towards. The 6-degree what he has given is the inclination of this slant surface with the vertical. This is inclination of the slant surface with the vertical. As we had discussed in the previous problems also, FBD of the block and wedge should be drawn simultaneously, but on the two sides, right? So that their working does not get mixed up. So we draw first FBD of block. So what will show here? 10 kilonewton is its weight. Normal reaction N1 and N, right? N1 will be exerted by the horizontal plane on which is resting, and N2 is the normal reaction between wedge and block. Then we draw FBD of this wedge on which force P is applied. Impending motion it is down, so friction will be up. Normal reaction N2, this N2 and this N2 are equal and opposite towards the body. This is towards the block, this is towards the wedge. Then as impending motion, the wedge is downward, friction will be upward, 0.25. This is N3 is the normal reaction between the this wedge and between the two wedges, you can say. N3 is the normal reaction exerted by the wedge which is stationary on the wedge which goes into motion. So this is N3 normal reaction. As this wedge tends to go down, friction will be in opposite direction, that is 0.25. This wedge surface is making 6-degree with vertical. So friction parallel to it will make 6-degree vertical. Normal reaction will make 6-degree with vertical. Now, this friction on this surface is upward. So on this surface, it will be downward, equal and opposite. Again, I repeat, as on this surface, friction is upward. On here, friction will be equal and opposite down. We'll start solving block first. So we'll apply equilibrium conditions on the block. First, we write sigma fx equal to 0, N2 is equal to 0.25 N1. Sigma fy is equal to 0, upward is equal to downward. N1 is equal to 0.25 N2 plus 10. Solving equation 1 and 2, you get N1 and N. Then we come to the FBD of the wedge, on which first we'll apply sigma fx is equal to 0. Sigma fx is equal to 0, N3 cos 6 to the right, N2 to the left, 0.25 N3 sin 6 is also to the left. Value of N2 is already known to you, N3 can be arrived. Then we write sigma fy is equal to 0. Sigma fy is equal to 0, upward force is equal to downward. P downward, equal to 0.25 N2 plus 0.25 N3 cos 6 plus N3 sin 6. This is what is reflected. 0.25 N2 plus 0.25 N3 cos 6 plus N3 sin 6. Substitute the value of N2 and N3, then you get the value of P, that is 1.639 kilonewton. As the weight was given in kilonewton, so all normal reactions and value of P will also come in kilonewton. Let's move to the next sum of the wedge friction. Problem number 4 on the wedge friction. Find the force F on the wedges A and B as shown in the figure, necessary to raise the weight of 50 kilonewton acting on the block C. Assume that coefficient of friction between all contact surfaces is 0.22. Inclination of the inclined face of the wedge is 15 degrees. See, mu is given to as 0.2, and the slant surface, inclined surface of this surface is talking about this surface. It is 15 degree with horizontal. This is 15 degree with vertical. First, we should understand that the given system has symmetry. So we'll take advantage of symmetry while drawing the free body diagram. Now, we need to first understand the direction of impending motion. He is asking you to find the minimum value of force F is required to raise the block. See, two wedges A and B on which force F is applied towards inward. So what will happen? The two wedges will try to go inward, or they will come close to each other. Wedge A will tend to go to the right, wedge B will tend to go towards left. All right. This way, the block will be raised. This way, the block will be raised. So we will draw free body diagram of this block. All right, and free body diagram of the wedge A or wedge B. We have drawn free body diagram of wedge A, on which force F is applied. All right, on this block, normal reaction is N1. This reaction also I have taken N1 only. Why I have taken this normal reaction as N1? Because of symmetry. You can see that the given system is symmetrical about a line which is passing through 50 kilometers. So N1 is there. Now this surface is making 15 degree with horizontal. So normal reaction will make 15 degree with vertical here. Then here this tends to go up, which does not make you to understand the direction of friction force. So we'll draw first figure diagram of wedge A. Wedge A definitely tends to go towards right. So normal reaction here is N2. This is N1. This N1 is seen, this N1 and this one. Equal and opposite towards the body. This tends to go towards right. So friction will be towards left. So this is normal reaction N2. Friction is 0.22 N2. This is 0.22 N1. All right. This surface is making 15 degree with horizontal. Friction is parallel to this 15 degree with horizontal. Normal reaction will be 15 degree with vertical. So here we write sigma Fy is equal to 0. Upward is equal to downward. Upward is N2. 0.2 to N1 sin 15 is also upward, is equal to N1 cos 15. That gets to the value of N2. Sigma Fx is equal to 0. F is equal to 0.2 to N2 plus 0.2 to N1 cos 15 plus N1 sin 15. Substitute the value of N1 and N2, you get the value of F. Hope this is all understood. So here we have taken distinct advantage of symmetry. Advantage of symmetry is always possible in any of the chapters of mechanics. Now we take next fifth problem on wedge friction. This problem is very special, has been asked number of times in the examination, and it has its directional impending motion of this problem is exactly opposite to what we have learned in the last 4 problems. Be little careful while understanding the solution of this sum. Two blocks A and B are resting against a wall and a floor as shown in the figure. Find the horizontal force P applied to the lower block that will hold the system in equilibrium. Take mu is 0.25 at the floor, 0.3 at the wall, 0.2 between the blocks. Given weight of block A is 500 Newton and B is 1000 Newton. Well, students, just see that what I have written here. To hold block A means block A is on the verge of going down. This is underline the statement. I repeat that to hold the block, he's asking you to find the value of P required to hold this block. To hold this block means this block is on the verge of going down. This block is on the verge of going down. If this block is on the verge of going down, this block will be on the verge of moving towards right. This will be on the verge of moving towards right. The problems which we have done so far, they were asking you, the wordings were like this. Value P required to raise this block. If this block is raised up, then this wedge will tend to move to the left. But in this problem, he's asking, the wordings are other way. What he's asking, find the value required to hold this block. Hold means what? This is on the verge of going down. All right. If this is on the verge of going down, the block B will tend to move towards right. This is what is the major difference in understanding this sum. Now we draw the free body diagram of the two blocks. This block is of weight 500 Newton, shown as it is. This is of block B 1000 Newton, has been shown as it is. All right, P has been shown as the external force. Now normal reactions. Here normal reaction, I've taken N1 towards the body, N2 towards the body, N2 towards the body. Normal reaction on this inclined surface, and N3. This block B tends to go to the right, friction will be to the left. So 0.25. Here this is to the right, this is to the left. This is 0.2. This surface is making 60 degree horizontal. So friction parallel to it will be 60 degree with horizontal. Normal reaction will be 60 degree with vertical as shown. Coefficient of friction on the floor is 0.25 and on the between the two blocks is 0.2. Then here this block tends to go down, so friction will be upward. 0.3 N1. This is N1, 0.3 N1. Since coefficient friction on the wall is 0.3. This friction 0.2 N2 has been marked as equal and opposite. Here we understood based on direction impending motion block to the right, we understood friction is down. So here friction will be down. After marking the direction of friction, then we mark the angles and show the result components. This surface is making 60 horizontal. Friction parallel to it will make 60 horizontal. Normal reaction will make 60 degree with vertical. Then we start solving it. Apply equilibrium conditions on this block first. Sigma fx is equal to 0. N1 is to the right. Plus 0.2 N2 cos 60 is to the right is equal to N2 sin 60. Sigma fy is equal to 0 is upward is equal to downward. Upward is 0.3 N1 plus 0.2 N2 sin 60 plus N2 cos 60 is equal to 500. Solving equation number 1 and 2, you get N1 and N2. Solving equation number 1 and 2, you get N1 and N2. Now we come FBD of block B. We'll write sigma Fy is equal to 0 first. You can say upward is equal to downward. Upward force is N3 is equal to N2 cos 60 downward, 0.2 N2 sin 60 downward, plus 1000. So upward force is only N3, rest all are downward. So that gets you the value of N3 as you substitute the value of N2. Then we write sigma Fx equal to 0. When you write sigma Fx equal to 0, forces towards right are equated to towards left. P is to the left plus 0.25 N3. P plus 0.25 N3 plus 0.2 N2 cos 60 is to the left is equal to N2 sin 60. Substitute the value of N2 and N3 into this equation. The value of P is arrived at 80.96. The value of P required to hold block A in position is only 80.96 Newton is the force what is required. So hope you all have understood the difference in the wordings of this sum and corresponding changes while drawing the free body diagrams. So with this wedge friction, 5 problems we have discussed. With that, all types of the problems, all concepts are covered. Now we move to the next type, that is ladder friction. Now we move to the next type, that is ladder friction. This is the third type of the problems what we come across in the chapter. Now first we'll understand what is ladder friction. We'll understand what is ladder, what is a concept of ladder friction. See, very often we use the ladders at home to fetch something from the higher elevation. Here we come across the ordinary type of the ladders where one end rests on the floor, another end rests on the wall. When the person is climbing the ladder, amount of friction that is generated between the bottom end of the ladder and the floor is most important. Ladder being example of general force system, three equilibrium conditions, sigma fx is equal to 0, sigma fi is equal to 0, and sigma m about any convenient point will be applied. There is nothing else. You need to understand only the direction of impending motion, and then we have to apply the friction and the normal reaction. This is another problem of general force system. Only the addition or the additional part comes is that only frictional forces. We have already done many problems of the bars and beams where in the equilibrium chapter without friction. Only thing is here friction force will also come into consideration. A ladder of 4-meter length weighing 200 Newton is placed as shown in figure. Mu B is 0.25, mu A is 0.35. What does it mean? Coefficient of friction between the floor and A is 0.35, and between the wall and the between the wall and the ladder is 0.25. Calculate the minimum horizontal force to be applied at A to prevent slipping. This is, you can see that force P has been applied to prevent the slipping. So you can see that the weight of the ladder length is 4 meter. Weight is acting at the center of length, that is 200 Newton. The person who is climbing the ladder is of what? 600 Newton. 600 Newton is the weight of the person who is climbing the ladder. So person is at 3 meter. Person is at 3 meter. Length of the ladder is 4 meter and its weight is 200 meter. Let's draw the freeboard diagram of the ladder. When the ladder is, we are drawing the freeboard diagram on this side. The ladder is, when the ladder is on the verge of slipping, the end which is resting on the wall will tend to go down. The end which is resting on the floor will tend to move towards left. Accordingly, friction will be shown. The end at end B, the friction will be upward 0.25 N2 as N2 is normal reaction. N1 is normal reaction at A. As impending motion is of the ladder is to the left, friction will be towards right. In addition to that, at point A, external force external force P will also be applied, which is applied to prevent the slipping. All right, distances are marked. The length of the ladder is 4 meter. This is 2 meter. So here this will be 2 cos 60. The person is has climbed up to the distance of 3 meter. So in this bigger right angle triangle, this is 3 cos 60, and in this bigger Wedge triangle, this is 4 cos 60. This is 4 sin 60. All these distances are marked with the understanding that you'll be taking moment about A. Why we'll take moment about A? There are two unknowns will go off. N1 and P will go off if you take moment about A. So we start with sigma MA is equal to 0. What will go off? P. What will go off? 0.35. What will go off? N1. Then 200 into 2 cos 60 is clockwise. 600 into 3 cos 60 is clockwise. N2 into 4 sin 60 is anti-clockwise. 0.25 N2 into 4 cos 60 is anti-clockwise. So that gets the value of N2. Sigma Fy is equal to 0 is gives you N1 plus 0.25 N2 is equal to 200 plus 60. That gets the value of N2. Sigma Fx is equal to 0. P plus 0.35 N1 is equal to N2. That gets you, substitute the value of N1 and N2, you get the value of P. So value of P required to prevent this ladder from slipping is 21.78. Okay. We move to the next sum. Let's see the sum. In the previous problem, diagram was given. In this problem, diagram is not given. So we'll have to create the diagram. I'm just reading from a ladder AB of length 3 meter and mass 25 kg is resting against the vertical wall and horizontal floor. The ladder makes an angle of 50 degree with the floor. A man of mass 60 kg tries to climb the ladder. Mass of the man is 60 kg. How much distance along the ladder he will be able to climb if mu between the ladder and floor is 0.2 and between ladder and the wall is 0.5. Also find the angle the ladder should make with the horizontal such that the man can climb till the top of the ladder. So students, it's a dual problem. In one problem, he has given inclination of the ladder is given and he is asking distance x up to which the man can climb. In the second part, he is saying that x is 4 meter, man can climb, x is 3 meter, because man can climb the whole distance or entire length of the ladder. And then he's asking the value of theta. So since unknowns are in such a way, I can cover the two parts of the problem in one free body diagram only. So what will I do that? I'll take a distance x which the man can climb along the ladder as unknown. I'll take theta also as unknown. Theta is the inclination of the ladder with the horizon. Let's see that. So now we draw the free body diagram of the ladder. We have drawn this is 3 meter, 1.5, 1.5. Man can climb up to distance x. Weight of the ladder is shown 25 to 9.81, 245.2. Weight of the man is 16 to 9.81, 588.6. First we'll show normal reaction N1 and N. The end which is resting on the wall will tend to go down. So friction will be up, 0.3. The end which is resting on the floor will tend to go to the left. Friction will be towards right. Now, in this right angle triangle, this distance will be 1.5 cos theta. In this right angle triangle, this distance will be x cos theta. And in the biggest right angle triangle, AB length is 3 meters, so 3 cos theta and 3 sin theta. First, we write sigma fx equal to 0, right? Point 2 n1 is to the right, is equal to n2. Sigma fy is equal to 0, upward is equal to downward, n1 plus 0.3 n2 is equal to the two weights, that is 245.25 plus 588.6. Solve equation number 1 and 2, n1 and n2 will be arrived at. Then we take moment about A. When we take moment about A, what will go off? N1, right? That's it. So weight of the ladder will give clockwise moment, 245.25 into 1.5 cos theta. Weight of the man will also give clockwise moment, 588.6 into x cos theta. These are clockwise moment. Anti-clockwise moment, N2 about A will give anti-clockwise moment, N2 into 3 sin theta. 0.3 N2 should be assumed against A. Upward 0.3 N2 into 3 cos theta is also anti-clockwise. Clockwise moments have been written on the left side. Anti-clockwise moments have been written on the right side. Now, in the first case, what he's saying? In the first case, he's saying theta is 50 degree and a value of x is required. So if you substitute theta as 50, substitute the value of N2 as 157.33, you'll get value of x. Whereas in second case, x value is given, man can climb up to the top. So that means x is 3 meter, N2 will remain same, 157.33. Substitute in the third equation, the value of theta is arrived at. A little simplification has to be done. So n theta and cos theta terms are to be put together and then clubbed, and then sin theta upon cos theta, that is tan theta is equal to 4.2206, which gets the value. So students, this problem was a dual problem. In one part of the problem, first part of the problem, theta was given, inclination of the ladder was given, distance x to which the man will climb was asked. In the second part, distance up to which the man can climb, that is 3 meter was given, all right, and theta was required. So we could cover both the parts of the sum into one equation. So we took theta as well as x as unknown. So in the first part, theta was given, x was found. In the second part, x was given and theta was found. Even if you solve this problem in two parts independently, then that also is okay. All right. We come to students now the third problem on ladder friction. Let's read this one. A 100 Newton uniform ladder, a 100 Newton uniform rod AB is held in position as shown in the figure. If the coefficient of friction is 0.15 at A and B, calculate the range of values of P for which equilibrium is maintained. Now, students, we have drawn the free body diagram. On this free body diagram, you see that this rod is resting on the wall and also resting on the A. You have to find minimum and maximum value of P. You have to find minimum and maximum value of P. P will be applied force, P will be maximum when end B tends to go up and end A tends to move towards right. P will be minimum when end B tends to go down and end A tends to go to the left. So both the cases have to be solved independently. You cannot club them. Now you come to this. This is, you have drawn the line diagram of the ladder AB. Length, it's 100 Newton, weight is acting vertically down. Force P is applied at the same point. Here normal reaction N1 and N2 are taken. This end tends to go up for P max. P will be maximum, then N B tends to go up. Friction is down 0.215. This end tends to go to the right. Friction is to the left 0.15. First, we'll write sigma Fy is equal to 0. Distances are shown. This is 40. So this half is 20. This is 16. Half of that will be 8. Sigma Fy is equal to 0. Upward is equal to downward. Upward is what is N1 is equal to 100 plus 0.15. Sigma Fx is equal to 0. P is to the right is equal to 0.15 N1. P is equal to 0.15 N1 plus N2. All right. Sigma Ma is equal to 0. When we take sigma Ma is equal to 0, N1 and 0.15 N1 will give you will get nullified. 100 into 8 clockwise, P into 20 clockwise, N2 into 40 anti-clockwise, 0.15 N2 into 16 is clockwise. All right. That's what we have left. P into 20 clockwise, 100 into 8 is clockwise, and 0.15 N2 into 16 is clockwise, N2 into 40 is anti-clockwise. Solve 3 equations. You cannot solve first 2 equations because 3 unknowns are there, 3 simultaneous equations are there. Solving the 3 simultaneous equations, you get N1, N2, N3. Our final unknown is P, that is nothing but P max, because we have drawn the free body diagram for maximum value of P. In the second case, this is he is asking minimum value of P required for the equilibrium. So value of P will be minimum when and B tends to go down and A tends to go to the left. All right. And B tends to go down. So friction here there is a correction. And B tends to go down. So this friction 0.15 and 2 is not down. It is up. You need to make a small correction. 0.15 and 2 is upward. All right. This end tends to go to the left. So friction is to the right, which is correct. While solving it, it has been taken properly only. As you can see that sigma Fy is equal to 0, N1 is up, 0.15 N2 is up, is equal to 100. Sigma Fx is equal to 0, 0.15 N1 is equal to N2. Sigma Ma is equal to 0. P into 20 clockwise, 100 into 8 clockwise. All right. N2 into 40 anti-clockwise, 0.15 N2 into 16 anti-clockwise. So two forces, P and 100 gives clockwise movement, N2 and 0.15 N2 will give anti-clockwise. So working wise, there is no correction into that. Only here, while there is a printing error, instead of shown this friction down upward, it was shown. As you can understand that if impending motion of is downward, friction will be upward. Solving equation number 1, 2, and 3, we get N1, N2, and P. The value of P is our final answer, and that is nothing but P. We move to the last problem of the chapter, or third type we are there, that is ladder friction. Problem number 4. A uniform bar has a mass of 35 kg. What rightward force P is needed to start the bar moving to the right? Take G is equal to 10 meter per second square and mu is equal to 0.3. This bar is of length 8 meter. This height is given to you as 4 meter. Force P is asking you to find the value required to start the motion rightward. That means this ladder or bar will tend to move towards rightward, upward, or you can say that. All right. Length of this bar is 8 meter. Weight will be concentrated at the center of the net. Weight will be concentrated at the center of the net. Let's see that how free body diagram has been drawn. This is 8 meter line diagram has been drawn. Weight 350 Newton will be concentrated at the center of the length. That is 4 meter from each end. Force P is external force applied. Normal reaction is N1 and N. This normal action. This inclination of the bar is taken angle theta with horizontal. This height is given to us 4 meter. This is 5 meter. So first we can get the cos theta value. Cos theta is going to be what? We can this is 4 meter. This is 5 meter. So we can write sin theta. Sin theta is 4 by 5. That is 0.8. And we can write now once theta is known to you, we can find the value of AD. But here I have found the value of AD using Pythagoras theorem in triangle ABD. In triangle ABD, AB is 5 meter, BD is 4 meter. So AD will come out to be 3 meter. How AD is 5 square minus 4 square, square root of that, that is 3 meter. So ABD is a right angle triangle where AB is 5 meter, BD is 4 meter, AD is 3 meter. Understood? Here the weight is concentrated at the center of the length 8 meter. So 350 Newton. So this will be 4 cos theta. All right. And this bar is making theta with horizontal. So friction, as this end of the bar tends to move to the right, friction will be to the left. This end here at B, B is basically fulcrum. B is basically a fulcrum where the normal reaction will be perpendicular to bar, and as this end tends to the bar tends to go to the right or upward, friction will be down. So 0.3 and 2. All right. So bar is making theta with horizontal. Friction parallel to that will make theta with horizontal. Normal reaction will make theta with vertical. So result components also have been shown. To begin with, we start with sigma ma is equal to 0. Why sigma ma is equal to 0 I have started? So that two unknowns will go off. What will go off? P and N1. 350 into 4 cos theta is clockwise. And can I take moment of N2 directly? Yes. Why? Force N2 is perpendicular to the bar. So force N2, that is normal reaction. And we know the distance AB. N2 into 5. You get the value of N2. Now, a question comes to your mind, why not the moment of components? Why we should take the moment of two components, as the value will come out to be same, but then it will be little complicated. And when the force is a perpendicular distance is already known to you of force N2, why should we resolve it? And moment of friction will be 0. Why moment of friction force 0.3 N2 will be 0? Since it is tangential to the bar, so it will pass through point. Now we write sigma Fy is equal to 0. Sigma Fy is upward is equal to downward. What are the upward forces? N1 plus N2 cos theta equal to 0.3 N2 sin theta since downward plus 350. So we have written it. Here N2 was already known. Substitute the value N2 in this equation, N1 will be arrived. Now we write sigma Fx is equal to 0. Sigma Fx, P towards right forces equal to towards left. P is to the right. That's it. Equal to 0.3 N1, N2 sin theta plus 0.3 N2 cos theta. Substitute the value of theta, substitute the value of N1, you get the value of P is arrived. So this way that we have covered 4 problems on ladder friction. Total, students, I have covered in 2 lectures on friction, 26 problems have been covered. In the first lecture, we had covered theory part, major theory part was covered, and 13 problems on block friction were covered. In the second part, I covered 4 problems of block friction with dimensions. So example of general force system. Then we took 5 problems on wedge friction, and the 4 problems were taken on ladder friction. So with that, I have covered all types of the problems which are part of MU syllabus. All right, students, you are requested to share the QR code of my video channel, YouTube channel with your friends so that they are also benefited. And many more solved problems on each type are given in the book of mine from which this content has been taken, that is Engineering Mechanics by Professor Ramkumar Agarwal. The book is available with the local bookstores. The book is also available on Amazon with free delivery, right? Link of Amazon is given in the video description of this lecture. Book has even MCQs also, as you all know that there is a possibility that examination this time will also be maybe partly MCQ based. All right, online examination maybe partly they may ask MCQs and partly they may ask the descriptive examination also. So the book has many MCQs in every chapter. So it will be good that if you buy the book from the local bookstore or from the Amazon. But even you are also requested to subscribe to my YouTube channel so that you'll keep getting the notification as and when I'm uploading the new video lecture. Thank you very much.